In this video, we're going to discuss graphs of trig functions. So learning objectives are we need to know and understand the shapes of each sine, cosine, tangent function's graph. And we want to be able to graph each of these functions. And also be able to identify and graph with transformation, which just means moving up and down, left and right, stretching. So transforming graphs. So let's review what sine function is. Sine function takes input measure as an angle, just like any trig functions, and the output is the vertical height of the point above the horizontal diameter. So let me write it here. Sine function takes input as an angle measure, and output is the vertical, this right here, vertical height above or below the horizontal diameter. Vertical distance measured in radius length. This is what sine function is. So how do we graph this? Okay, so when we graph sine function or any trig function that matter, here's a very, very important thing. The x-axis is the angle measure, specifically in radian. Oftentimes is in radian, and I'll explain that in a second. It's also possible to graph in degrees, but radian makes more sense. And y-axis is output, the sine value. So why does radian make more sense when we graph sine function or cosine tangent also? It's because radian is a real number, and in terms of scale, look at this number. Here we have a pi, right? Pi is about 3.14. So if y-axis is scale in 1, 2, -1, -2, we have a same scale on x-axis as well right now. If 1 will be somewhere here, 2 will be somewhere here, 3 is just below, just left of pi. So it is easier to have a same scale with x and y axes using radian. But imagine if we use degrees. Pi is equivalent to 180 degrees. It just doesn't match up. This is one unit is 1, but here to here is 180 degrees. 1 degree is somewhere here. So if you were to have a same scale between degrees and y-axis, the sine value, output value, it doesn't quite make sense in terms of having a same unit. But here, essentially, we have a same unit. We just didn't mark it, but if 1's here, 2's here, 3's a little smaller than pi, and 2 pi's here, it means here is about 6. So having radian, we can have a same x and y scale, the unit scale. Okay. So keep that in mind. And also important thing is that we have an angle measure in the x-axis. Okay. So for example, we know that sine pi over 2 is 1 from the unit circle. So essentially in graph of sine function, we're graphing values from unit circle to graph. Of course, the graph contains more values than unit circle because it will be continuous line. But let's look at this. Here, this is angle measure, which means this goes to x-axis. So when angle is pi over 2, the corresponding sine value is 1 right here. So then I'll draw a dot right here. Here's a 1 value. And we can do this for all the values, but we just need enough to graph. So we know that sine of 0, for example, is 0. Sine 0 radian is 0. So then angle 0 is right here, and y-axis 0 is also here. So we have another point right here. Let's do one more, for example, and I'll show you a full graph the next page of sine function. So sine pi is also 0. So again, this is the input angle right here, sine pi. When angle is pi, the corresponding sine value is 0. So we have another dot here. And similarly, sine 3 pi over 2, or let's also do sine pi 3 pi over 2. Sine 3 pi over 2 from unit circle will give us -1. So that means when angle is 3 pi over 2, the corresponding sine value on y-axis is -1. So we draw that here. Sine 2 pi will give us 0. So we connect these. And of course, how do we connect does matter. Okay. And I'll show that in the next page. But for now, just on this page, remember that input quantity is angle measured in radian. This is very important. Okay. So here's a graph of sine function. So the left side is the unit circle that we previously saw, right? Unit circle. But unit circle is also x and y axis. So how they're different? The way they're different is that on the unit circle, the angle measure is actually drawn. Here's the pi over 6, pi over 4, pi over 3, pi over 2. Angle measure is drawn with the initial and terminal ray. Whereas the x and y axis graph of sine function is that angles are listed in a radian in the x axis. So for example, pi over 6 right here corresponds to this angle. So what is the sine pi over 6? This value right here, this half. Okay. Sine pi over 4 is square root of 2 over 2, so right here. So we plot all these points on x and y axis in order pair. And that's where we get this graph. And we actually continue. Do you see this arrow? It goes for like this forever. And I'll show that in the next page. So just remember that we are using unit circle values to plot the points on the x and y axis to graph sine graph. So that's the difference. Okay, so let's go to the next page. Here's the graph of sine function. And let me point out a few things. Here's an arrow. Here's an arrow right here and here. So it actually repeats the same shape forever, unlimited, infinitely. It repeats. Okay. The reason why it repeats is because coterminal angle. For example, sine 0 is coterminal to sine pi. Oh, excuse me. The angle 0 is coterminal to angle 2 pi, right? That's why these two have same values. Similarly, pi over 2 is a coterminal to pi over 2 plus pi, which is 3 pi over 2 right here. These two are coterminal to each other. So they have same. Oh, actually, I did addition wrong. I'm sorry. After 2 pi. For coterminal, we have to add 2 pi, right? Which gives us pi plus pi over 2 plus 4 pi over 2 gives us 5 pi over 2. 5 pi over 2 is right here. 5 pi over 2. So sine pi over 2 and sine 5 pi over 3 has same output. That's why the graph repeats forever, because of the coterminalness of angle. So this is very unique. The unique feature of trig function is that it repeats. It repeats same shape, certain segment. It's because of the coterminalness of angle. Okay. So let's examine this graph a little more. If you look at right here, let me just erase to make it. I'll just know that it repeats. Let me draw an arrow here, just in case you cannot see the arrow. It repeats. So do you see these dots right here? These are referring to unit circle values. We can use unit circle values. Let me draw more dots here to sketch these. So we know that sine pi over 4 is square root of 2 over 2, which is a little bigger than half. And here we have pi over 6. This is pi over 6, which is half. And here we have pi over 3, which is square 3 over 2 right here. And pi over 2, we have 1. Okay. So essentially, we're just graphing, we're plotting all the, let me highlight it, all these points are plotted from the unit circle, and we connect them. Okay. And when we connect, it is smooth curve. Sine graph is almost never a straight line. It may look like a straight line if we zoom in, but it's always this wavy curve. Okay. And it's also not a perfect half circle, so it's not really like this. This looks like a half circle each, right? It's more like this. I don't know if that was any better. Let me actually sketch it. So when we sketch this, draw 0 and 2 pi. That's the full rotation. Here's half of 2 pi, which is pi. Half of that is pi over 2. Here's 3 pi over 2. And it goes as high as 1 and as small as -1. So actually, let me draw on to scale. So pi over 2 is little bigger than 1. So the y-axis should be little. 1 should be somewhere here, because I'm trying to draw on scale. It doesn't have to be perfect, of course. So this length should be little smaller than this one, because pi over 2 is 3.14 divided by 2, which is a little bigger than 1. So then sine graph, sine 0, I like to draw these 5 dots. And yeah, they curve like smooth. And like this. This is Australia, yeah, so and draw an arrow. Make sure put an arrow to indicate that these go, the graphs continues. So this is the basic graph of sine function. So let's make some observation of what are some characteristics of sine function. First of all, they're periodic with period of 2 pi. This means that it repeats every 2 pi, repeats shape every 2 pi. So 0 to 2 pi, 2 pi to 4 pi, 4 pi to 6 pi, also negative 2 pi to 0, -4 pi to -2 pi. It has the same shape. The domain is negative infinity to positive infinity. So what is the domain of sine function? Angles. We can input any angles in sine function, and in return, it will give us some kind of output. And range is -1 to 1. That means that sine value cannot be greater than 1. It cannot be less than -1. It's always between -1 and 1, inclusive. So it could give us -1, it could give us 1, but not anything bigger than 1, not anything less than -1. Sine graph is also symmetric about the origin. So here's the origin, and if you were to rotate it, or if you can reflect on this point, we'll get the exact same graph, and that's also known as odd function. So key way to remember the shape of sine is that sine graph crosses the origin, 0, 0. When angle is 0 radian, the sine 0 is 0. So let's look at cosine graph. Well, what is cosine function? Cosine function also takes angle input, and it measures the horizontal distance point. It should be actually right and left side of the vertical diameter. So essentially, this distance right here. So cosine function takes input angle and output is horizontal distance. So that's why we use this x right here for horizontal. But don't get confused, this x with the x and y coordinate will be graphing the cosine function. Okay? Because no matter what, when we sketch sine cosine function and tangent function later, is that input, this x represents angle in radian. Okay? So for cosine function, it has this shape. And it does look similar to cosine function, or excuse me, sine function, right? But difference is that for cosine, let's plug some values. Cosine 0 is 1 from the unit circle. So when angle 0, the cosine value is 1. That's why we start from here. And it has this shape. Cosine pi is -1. That's why when angle is pi, it's -1 right here. And yeah, we can do some more value, 2 pi, pi over 3, so excuse me, 3 pi over 2, or pi over 2. Okay. So these are just values from unit circle, and then we connect them. Okay. So unit circle values are a good guideline to start sketching the cosine sine graphs. Okay. What are some characteristics of cosine function? They're also periodic with a period of 2 pi. It repeats every 2 pi. So in this case, from here it has this shape forever. This shape forever. Okay, left and right side. Domain is negative pi to pi, means you can input any angles, and range is negative 1 to 1. So cosine value cannot be greater than 1, less than negative 1. And graph of cosine is symmetric of a y-axis. That means if you rotate around the y-axis, they're the same graph. So cosine is an example of an even function. So let's look at this example. It's a multiple choice. Explain why does a sine function graph have the characteristics of repeating pattern in every period. Okay, so I suggest you pause the video and try this problem. And when you got the answer, it's a multiple choice A, B, C, or D. Come back and check this answer that I'll go over. The correct answer is because B, because input value, the angle measures, have coterminal angles. So pi is coterminal with 3 pi, for example, coterminal with 5 pi. Again, we do not say these angles are same angles. We say they're coterminal to each other. But we can say that sine pi equals sine 3 pi, for example. They have the same output. Also for 5 pi. But we do not, absolutely, we do not say pi equals 3 pi. That just doesn't make sense, right? The pi is 3.14, about 3.14. This would be about 9 some number. So they're not same number. They're coterminal angles in terms of angle measure. So we have this different types of function. It's actually not different. It's more of a applied sine cosine function. Sinusoidal function is that once we have a sine and cosine function, we have some transformation. We move it up and down, left and right, stretch, or shrink, or we can also flip. Okay. So that's all this is. Essentially, transformation applied to sine cosine function. Okay, and here's a generic formula, and either we can use this one or we can use these two. Either one's fine. Okay, but in general, oops, let me actually delete this part. Let me highlight it. In general, this is the part that problem is usually given, and you can factor b out. You can factor b out to get this inside parenthesis, inside a bracket. Okay. So what does each of letter represent? Well, A represents amplitude. Controls amplitude. That's the height. We can say height of the sine cosine function. And B controls the period. And period actually stretches or shrinks the graph left and right horizontally. C over B is the shift graphic horizontally. In trig function term, we use phase shift. We call it phase shift. And lastly, this number D right here, plus D, we call it vertical shift, also known as a midline in trig function. So let's look at an example of all each of these components: amplitude, period, phase shift, and midline. Okay, let me write here midline. So this is how amplitude is applied. If you look at this right here, look at 1 sine x. Again, this x represents angle. That's always implied in trig function. Sine, cosine, tangent, secant, cosecant, cotangent. The variable inside represents angle measure. So this is the same as just sine x, right? Regular sine x. And the red graph right here, this red graph right here is the sine function. Now, once we multiply 2 to the sine function, the height, which actually the precise term is the amplitude, increases. So the blue graph right here is the 2 sine x. And 3 sine x is even longer amplitude, and 4 sine x even longer. Okay, so that's what happens to amplitude. So how can we make it less than, like shorter amplitude than 1 sine x? You might think that maybe a negative number, but if you actually multiply a negative number, it flips the graph. So if you want a shorter, we need half sine x, for example. Then it will be amplitude will be half. So graph will be look something like this. If it's shorter amplitude, this will be about half sine x, and 1/3 sine x will be shorter amplitude, and so forth. Okay, so that's what amplitude. It controls the. We can describe the best way to describe amplitude is high from the midline of the graph to the highest line, highest point and lowest point. This distance is called amplitude. This distance is amplitude. So it can be 4, 3, 2, 1, depending on what numbers multiplied in front of each trig function. And cosine, the same thing applies. What is period? Period is the segment, amount of segment that repeats. Okay, repeats this shape. So for sine x, it repeats every 2 pi. So it has every 2 pi this, and it continues every 2 pi, same shape every 2 pi. For sine 2 of x, now we have to be careful here. This means that we have sine function, and input quantity is 2 times x. Not just the angle, 2 times the angle. So for here, if I want to plug pi over 2, I plug pi over 2 here, 2 times pi over 2 becomes just pi. Okay. So input is already multiplied by 2, and we input that into sine function. So in this case, period actually gets smaller. So if you look at the red graph, this is 1 period. It repeats every pi now. Every pi. Okay. So if you can imagine the blue graph shrinking this way, getting narrower, kind of like the elevator door closing direction, that's what we get the red graph. If you have sine x over 2, which means we're dividing the input quantity by 2, we have a longer period. So for the green graph, the period is actually start from here and like this, 4 pi. The period will be 4 pi, like this, and repeats this direction, of course. And the way we find the period is two pi over b. And what is b? B is the number multiplied in front of the x. In this case, calculator period here, period for sine 2x. Of course, you can, for this one, we know by the graph also, but oftentimes we need to actually calculate it. So it'll be 2 pi over 2 gives us pi. That's why this is the period. For here, period is 2 pi over b. Here, this is the same thing as half times x. So 1/2 is multiplied. We get 2 pi times 2 over 1 gives us 4 pi. So that's how we got 4 pi as a period for this function, sine of x over 2. So this is how a period looks like when we apply. Phase shift is horizontal shift, going left and right. So sine graph we have here. Now if you have x minus pi over 4, this means phase shift right to the pi over 4. Okay. So why right when we're subtracting? Well, one way to calculate this is what makes inside the input 0. X minus pi over 4 equals 0. Well, x is then add pi over 4 both sides. It's pi over 4, right? That means positive pi over 4 is a phase shift. That means right pi over 4. So that's why we shift blue graph to the right. Whereas the green graph, if you look at here, x minus pi, right? Well, I need to have a pi here to make inside 0, right? That means we have a phase shift to the pi. So let's look at the graph. Let's look at the blue and red graph. Here I have a blue graph, which is just regular sine x. I move entire graph to the pi over 4 amount. So I move to the right, pi over 4 amount. And we get this red graph, pi over 4. And the green graph, we move pi over, oh, excuse me, just pi amount. So entire graph, blue graph, move to the pi, this to pi, this to pi amount to the right. Then we get phase shift. So phase shift, when we deal with the phase shift, same for the cosine, we have x plus some number. And that number can be negative, that number can be positive. So if I have sine of x minus a, then a is the phase shift. So actually it'd be better to just write minus. If you have sine x plus b, then negative b is phase shift. Whatever makes 0 inside is the phase shift. You just write PS, short for phase shift. Okay. Vertical shift is also known as midline, and we notate this midline using y equals equation. Y equals. So in this case, sine x is y equals 0. That's the midline of the graph. It goes through the middle of the graph. Well, when I do plus 2, that means I move entire graph up 2. That means that y equals 0. Now, for this one, y equals 2 is the midline. So vertical shift or midline allows to move the graph up and down. So if I have sine x minus 1, let's say that's another function, midline will be right here. And I have this graph, sine graph, like this. We have this one right here. This will be the sine x minus 1. So it's like a straight line, but I meant to draw a curve. Okay, so let's look at tangent function graph. Tangent function relates angle measure to slope of the terminal wave angle, right? So remember, if this is the angle, the tangent measures this slope. And we'll calculate it by changing output over changing input, which also happen to be same thing as sine over cosine. So for tangent function graph, we collect all the angles and its corresponding slope and plot those points. And we get something like this shape. Let me explain this shape. So for tangent graph, it repeats this every period. And for tangent function, period is pi. So it repeats this forever. So we don't say we have 3 tangent graph right now. This entire thing is one tangent graph. Again, this is repeating, it repeats like this forever. Okay, we have infinite number of this shape. Okay, so that's the first thing you need to keep in mind. Why do we have this shape? Okay. Sorry. Why do we have this shape? So let's look at the unit circle. That'll help us determine. So let's just look at this portion right now. I think this will help us determine. So this right here is from pi over 2 to 3 pi over 2. So it's pi over 2 to 3 pi over 2. 3 pi over 2. So what's happening is that at pi over 2, this angle right here, we have pi over 2. The vertical line slope is undefined. That's why at pi over 2, we don't have a corresponding tangent value. Okay? It does not exist because tangent pi over 2 does not exist because slope does not exist for vertical line. Same for 3 pi over 2. Vertical line slope does not exist. That's why tangent value doesn't. It just it approaches this forever. It approaches this dotted line, which is also known as asymptote. It approaches line forever. Okay, so let's keep that in mind. So let's look at this. So then what about this angle right here? Okay. This angle, slope is negative, negative slope. And as we change the angle like this direction to up to pi, at pi, slope is 0. That's why we get this value. So slope is actually increasing. So bigger, negative number is getting smaller. Oh, sorry, negative number is getting bigger. Getting bigger, 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 it gets approaches 0. So that's why we get this shape. Slope starts at negative, it gets bigger and bigger, gets 0, up to get to 0. Now after pi over 2, slope now is positive. This is positive slope, right? That's why slope now is above the x-axis, and slope gets bigger and bigger and bigger. That's how we get, and oops, that's terrible. Sorry. Start from here. Now look at, as we have an angle getting closer and closer to 3 pi over 2, slope gets infinitely large. That's why we have an arrow goes positive infinity. And same kind of thing repeats on this side also. That's why we'll get the same shape graph here as well. Okay? So that's where we get the tangent graph. And well, how about here then? Same thing, we have 0, pi over 2. Here we have negative pi over 2. Negative pi over is also here. Negative pi over 2, we think from start from here to here. Okay? And negative 3 pi over 2, then will be here. So from here to here. So we do the same process of observing slope of each terminal ray of the angle. Then it follows this pattern. That's how I get the tangent graph. And tangent graph is also repeating each period because of coterminalness of angle. Okay. So what are some characteristics of tangent function? It has a stretching factor of absolute value of a pi. So we don't call it amplitude, we call it stretching factor for tangent function. And period formula actually is different. It's pi over absolute value of b. Not 2 pi like sine and cosine, it's pi. Because period of tangent function itself is pi. And domain is not always a number. We cannot include these domains, right? Because we do not have slopes on those values. But range is everything. For tangent value, range can be any value. And it has asymptote, which is this line. We can find the equation of these lines actually by following this right here. And tangent without any phase shift, it's an odd function. Phase shift and without any midline, it's an odd function. So let's look at this example. Explain why the terms of slope, in terms of slope of terminal A, why tangent pi over 2 is undefined. Okay. I suggest pause, try on your own, and come back. Well, it's because terminal A angle pi over 2 is vertical line, and slope of vertical line is undefined. That's why. So when we try to evaluate tangent pi over 2, well, this is undefined. Because vertical line slope is undefined. Why? Well, remember slope is changing y over changing x. So this is how much changing x. This is changing y. It goes from here to here. Go up that amount. But how about x direction? There's no changing in x direction. So when we do change in x, so a change in y over changing x, there is no change in x. So we would quote unquote divide by 0, which is undefined. And this, of course, can be verified with sine pi over 2 over cosine pi over 2. And cosine pi over 2 is 0, where sine pi over 2 is 1. Okay. But here it says explain in terms of slope of terminal ray. Well, vertical line slope is just undefined. That's why tangent of pi over 2 is undefined. Because tangent represents slope of terminal ray.